All right, today in class we discovered slope-intercept form. We saw that there was a special equation or a special form of a linear equation that gave us two very specific pieces of information about a line. What we're going to do now is we're going to learn how to graph linear equations using slope-intercept form. Now, we have already graphed linear equations. We've graphed them two different ways so far. It's been a while. You may not remember a whole lot, maybe a little fuzzy, but at the very beginning of Chapter 3, first thing we did, we looked at 3-column tables, and we picked our x values, and we plugged them in, and we found our y values, and then we graphed the line. That was one way of graphing linear equations. Not hard, but a little bit of a pain, took a little bit of time. Then we looked at graphing using the x-intercept and the y-intercept. Those equations were usually in standard form. We talked about standard form. We plugged in 0 for y and we found the x-intercept. We plugged in 0 for x, we found the y-intercept. Again, not hard, but works best in certain situations. Sometimes there will be equations where we would get fractions for the x-intercept and the y-intercept, which we could handle, but we'd rather not. So we're going to like slope-intercept form pretty well. It's pretty simple. It's easy to graph, not a lot of trouble. This is probably going to be our favorite way to graph. Okay? Now, let's just review from today. We said that slope-intercept form was a linear equation in the form y equals mx plus b. X and y, remember, are coordinates. Those are points that are on the line. M is the slope of the line, and B is the y-intercept. That's where the line crosses the y-axis. Okay? So, those are the two pieces of information that slope-intercept form gives us. Now, they're going to give us equations today, and we're going to graph them using slope-intercept form. Here's what we do. The first thing you need to do is make sure the equation is in slope-intercept form. Which basically is just another way of saying isolate y, right? We want y isolated. We've been doing this since the end of Chapter 2, where they gave us an equation. At the time, we didn't know it was a linear equation, and they told us to isolate y. That's why we started that way back then, is because we needed to do it now. Okay? So look at this equation here. Y equals 1/4 x minus 5. Is it in slope-intercept form? Is y isolated? And it is. So we're good. Okay? Step 1's already been done for us. Step 2 is going to be to identify M and B. We're going to identify the slope, and we're going to identify the y-intercept. So for this equation, remember M is the coefficient of x. So M is the number in front of x. So M is 1/4. And B is the number at the back. It's the y-intercept. In this case, B is -5. Notice I included the sign with it, -5. Okay? So identify M and B. Step 3 is plot B on the y-axis. This is important. This is very, very important. B is the y-intercept, so it goes on the y-axis. Okay, so B is -5. So on the y-axis, I'm going to plot a point at -5. Okay, It goes on the y-axis. One of the biggest mistakes will be people putting this on the x-axis, so make sure you're paying attention. Now, how many points do we have to say we have a line? We got to have at least 2. I'm going to tell you to put 3 if there's room. Here's how you get your other points. You're going to start at the y-intercept. And you're going to use the slope, which we've said is rise over run, to find other points. Okay, so let's look at my slope here. My slope is 1/4. And we've said that one way to look at slope is that it is a line's rise compared to its run. So the top number is the rise, the bottom number is the run. Rise is the vertical change, that's the change in y. Run is the horizontal change, that's the change in x. Now, you want to put your pencil on the y-intercept. Don't start back here at the origin. Go down to the y-intercept, and you know those triangles we drew to do slope on a graph? That's what we're going to do. My rise is 1, so I'm going to rise 1. My run is 4, so I'm going to run, that's horizontally, positively, 4 spots. 1, 2, 3, 4. And I'm going to put another dot. Notice my rise is 1, my run is 4. You're not going to have to write that every time, but that's what we're doing, okay? Now, that is only 2 dots. I can't go again. I can't go if I go up 1 and over 4, I run out of room, and we don't want to go off the graph over here, okay? But we can reverse. Instead of going up 1 and right 4, we can go down 1 and left 4, and that'd be the same thing. So that's what I'm going to do. I'm going to go down 1, left 4, put another dot. That gives me 3 points. I draw a line through them. I put arrows on the end, and I write the equation of my line. Y equals 1/4 x minus 5. Okay? All right, go to the next slide, and let's do some more examples. Okay, let's look at this one. Y equals negative 2x plus 5. What was step 1? Step 1 was make sure the equation is in slope-intercept form. Is this in slope-intercept form? Is y isolated? It is. Okay, what was step 2? Step 2 was to identify m and b. Okay, what are m and b in this equation? Well, m is the coefficient of x, that's the number in front of x, so m is negative 2. B is the number at the back, b is 5. Okay, that was step 2. What's step 3? Step 3 is to plot b on which axis? On the y-axis. So I'm going to go up 5 since it's a positive 5, and I'm going to put a dot on the y-axis. That's my y-intercept. That's where the line crosses the y-axis. Okay? So I have 1 point. I need at least 2. 3 is better. My slope is negative 2. Now, I need to use slope as rise over run, which means I need a fraction. How do I change negative 2 into a fraction? Well, I put negative 2 over 1. So, put your pencil at the negative 5, and I'm going to rise negative 2. How do you rise negatively? You go down. So I'm going to go down 2, and I'm going to run 1. But notice the 1 is positive. The 1's not negative. The 1 is positive. So I'm going to run to the right 1 spot. Okay? I've got 2 points. Do I have room to do it again? I do. I'm going to go down 2. I'm going to go right 1. And I'm going to put another point. I've got 3 points. I'm going to draw a line through them. I'm going to put arrows on the end. And I'm going to name it. Y equals negative 2x plus 5. All right, look at the next one. Y equals 2/3 x. Is it in slope-intercept form? Is y isolated? Yes, y is by itself. Okay, now we need to identify m and b. M is the coefficient of x, so M is 2/3. Now, what's B? What do you think? What is back here? Nothing's back here. When nothing's back here, it's plus 0, right? We didn't add anything to that, so B is 0. All right, so M is 2/3, B is 0. We plot B on the y-axis. Where is the y-intercept of 0? Where do you think? It's at the origin, okay? Now I'm going to take 2/3. I'm going to use that as rise over run. I'm going to put my pencil on my y-intercept. I'm going to rise 2, so I'm going to go up 2, and I'm going to run 3. So I'm going to go to the right 3. Put a point. Then I'm going to rise 2, run 3, put a point. I'm going to put a line through them, put arrows, write my equation. All right, here's another one. Y equals negative x plus 7. Is it in slope-intercept form? Yes. Y is isolated. What are M and B? Well, which one's the obvious one here? The B, right? B is 7. What do you think M is? What have we said when there's a minus sign in front of a number? What's really there? It's a negative what? A negative 1. So M is negative 1, okay? Now that we know M and B, I want you to pause the video and I want you to try to graph this. Now, I just noticed I messed up. I gave you a graph that went to 6 and you need to 7, so you're going to have to go off the graph here a little bit, and that's okay. Sorry about that, but that's all right if you go off the graph a little bit for your y-intercept. But you try to graph this and then turn the video back on and see if you got it. Okay, how'd you do? Notice I put the negative 1 over 1 to make rise over run. I went down 1 and right 1. And then I got my line. Now, let me point something out that you can check. The slope of this line was negative. So how's my line facing? It's going down from left to right. Okay? Now, look at graph x plus 2y equals 4. What's wrong with this one? It's not in slope-intercept form. So I want you to pause the video and I want you to isolate y. I want you to put this equation in slope-intercept form and identify M and B. All right, did you get y equals negative 1/2 x plus 2? Check your work up here, make sure you did it correctly. We get M is negative 1/2 and B is 2. Now I want you to pause the video, graph this line, and then turn the video back on and check it. Okay, there's the line. Let me give you a little tip. When the slope is negative, either the rise are negative or the run is negative. You can't make them both negative because a negative over a negative would be a positive. So here's what I do. I always, if the slope is negative, I make my rise negative. That way I'm less likely to mess things up. So if your slope is negative, make your rise negative. Okay, that's why I went down 1 and right 2. I always make my rise negative. Do this one all on your own. Pause the video, put it in slope-intercept form, graph it, then turn your video back on and check it. All right, make any corrections you need to. Notice how I put the negative with my rise, so I went down 2 and over 5. Notice I ran out of room, so I had to reverse. So instead of going down 2 and over 5 again, down 2 and right 5, I went up 2 and left 5. You can always reverse your slope to get another point. Okay? Write any questions here. We'll do some practice with this tomorrow.